All right, let's get going. So we've covered environment variables, sensitive security. We've covered mass assignment vulnerabilities. We've covered SQL injection attacks. Edgar, I'm going to ask you to also remind me to add mass assignment vulnerabilities, assign it, try to figure out how to map it to this top 10 as well, okay? Because it is a very common form of attack, as you've seen, all right? Okay. Moving on, next topic, ID numbers. All right. Thus far in our database, and folks, I'm going to ask you, please, like, do your debugging later, okay? um, thus far in our database, we have been using ID numbers for our records, and we have been using, in particular, auto incrementing ID numbers. So your database will, give an ID of 1, and then 2, then 3, then 4, as you are adding more and more records, right? So these are what we call these sequential IDs, all right? It's great. There's a lot of advantages of having sequential IDs. It's easy to debug, right? Like if you're debugging and you create two records, you know which one came first, right? And they're short, so you can even type them in by hand, all right? And also, they're really nice sometimes for the user. Like a user may take your URL, if it's like, if my URL is, credence slash project slash one, they can even remember, they don't even have to bookmark it, they can remember it in their head. And they can easily find resources by just entering their ID number, which is sometimes kind of nice, okay? Also, sequential IDs they have very good performance characteristics if you're doing very high rate of insertions and or updates or joins, because it's very easy for your database to treat these IDs as arithmetic, as numbers, and it can very intelligently sort things and do interesting things with it. Okay, so sequential IDs are great, except when they're not. The disadvantages are the following: attackers know exactly how many resources you have, right? Like if somebody came to my Credence application and made a project and their project ID was, I don't know, like 35, they know exactly how many projects were made before me. And they know the ID of the next project that's going to go in the database. It's going to be 36. It's possible they can use this information to their advantage in some way. Okay. First of all, they know the ID numbers of 34 other projects in my database, 1 to 34, right? So they literally know the ID numbers. They may not be able to access it, but they know where it is. Now they just have to do the second part of the attack, which is to figure out how to fool the authorization somehow. But they've at least figured out how to access the resource directly, right? So having ID numbers that are guessable and understandable comes with this down risk. Interestingly, it can have some other ramifications. I had this someone contact me. This is several years ago, many years ago. Well, 5 years ago, and he said, "Hey, Soumya, Professor Ray. Sorry, not Soumya. Professor Ray. I've come to hear of you. And by the way, I'm a serial entrepreneur, and I've got a few different startups in Taiwan. And I've got a new one that I just created. It's actually a startup to help entrepreneurs. And it was a very interesting site. And he told me, look, listen, I'd love to talk to you sometime to rack your brain about some issues around development. He's like, I've got a developer, but I want to talk to you a little bit about like, he's like, I'm not, he's like, he himself is not personally a developer. So he wanted to talk to somebody about management and development, managing developers and stuff like that. And I said, okay, cool. So you've got the startup. And I was like, hey, how popular is it? Like, is it already launched? He's like, yes, it's launched, and it's got it's got a few hundred users already, to be honest, not more than that. Okay. Good thing he was honest, because what do? I go on his platform and I create my own user account. And right away on top, I see the name of the website slash, and I go to my profile and it's like slash users slash like 277 or something like that. So I know right away how many users he's got. So luckily he was not lying to me. But it'd be funny if he said, "Yeah, we got thousands of users." I'm like, you got 200. So it can actually embarrassingly give away some information when you're not expecting it. But my point is this: it gives away information. Okay, how people exploit that information is up to them and who they are. All right. So attackers know resource counts. It's easy to guess the next or previous URLs. They already know the URL. They just have to figure out how to spoof the authorization now. You made half of it for them. Um, it also has another potentially interesting problem, which is that when you actually insert into the database, you typically it's the database who's doing the auto increment. If you're especially if you're using a real database like Postgres or Oracle or MySQL, it's the database that does the auto increment. So you have to insert something into the database, and then the database has to tell you this was the ID number that I created. Okay, so it's kind of interesting. Like you have to, you cannot do it in one shot. You cannot tell the database what ID you want to use. All right, so I don't know if that's a downside, but maybe there's an issue there. Okay. That's one thing, but there's another. I'll put a link here. More negative issues that people talk about with sequential IDs. These are the three that resonated with me, but there's some others, right? But it does bother me though that, like, if someone's out to kill me, God forbid, I don't want them to know my address, right? Like that's half my security is they don't know where I live. Once they know where I live, then it's the problem is solved. They just have to figure out how to get into my house, or they just have to wait outside my house for me. Similarly, I don't want people to know sometimes where sensitive records are. Some records are fine, they're not a big deal. But for really sensitive records, which may contain really confidential information, I don't want them to even know the address. So it sometimes feels a little weird that I have something sensitive and somebody knows the URL of it, and the only thing preventing them from getting in is like the authentication and authorization. A little bit of anonymity doesn't hurt sometimes. I'm just saying. Okay. So for that reason, sequential IDs are sometimes not favored. A common, a popular alternative to sequential IDs is called universally unique IDs, universally unique identifiers, or UUIDs. How many of you have heard of UUID before? Heard of UUID? One, two, three. Is that a hand, Ken? One, two, three, four, five UUID fans. Okay, so a UUID looks like this. It looks like this. These are three UUIDs, not one. Okay, so these are three different UUIDs. They're usually pretty big. So Wikipedia to the rescue. UID is an identifier used in software construction. It's typically 128-bit value. All right, so 128 bits long. So bigger than the size of or bigger than many integers we're using in our computing. Okay. So there's many versions of UUID. There's version 4 right now. Microsoft has its own version of UUIDs called GUIDs, globally unique IDs, but it's got some other characteristics which I believe are good, but it's Microsoft's thing. UUIDs are more popular. So version 4, I don't know, there might be a version 5, I don't know. If there is, someone please tell me. So it's a scheme relying only on random numbers. So these numbers are entirely random. With the only number that's not random is this number right here. There's one number in here, which is the number 4, telling you which version this is. Okay, it's version 4 of UUID. All right. All the other remaining 122 bits are set. Excuse me. Sets the version number as well as two reserved bits, Y and Z. And Y and Z are reserved to be the numbers 8, 9, A, or B. I don't know what it's for. Is it a checksum? I'm not sure. It could be. It could be a checksum. Huh. If anyone can tell me why it reserves those, I'll be very curious to know. Like after 4, the first digit of the next set, Y is reserved. Where is Z? Is Z one more at the end? I can't remember. Anyway, so but all the others are purely random numbers. Okay. So let's do this. 100 and let's kill the server. IRB. How many bits? 128 minus. So I think altogether it said there's 3 digits that are reserved, 2 or 3 digits that's reserved, and the remaining 122 bits are random. Okay, 122 bits. How many combinations can we have from 122 bits? Each bit can have how many combinations? A bit, not a byte, a bit. What is a bit? Bit, not a byte, not a kilobyte, not a megabyte, not a gigabyte, a bit. 2, 0 or 1, a bit. Yes, right. Gonna stretching is not enough. I'm gonna hang you all by your ankles outside the window as well. A bit. 2. How many possibilities are there with 122 bits? How do I figure it out? 2 to the power 2 to the power. That's Ruby's version of to the power 122. Wow. How much sand in the oceans? I won't do that again. I won't do that again. Yeah. But that's a mighty big number, right? How big is that number? To put this into perspective, the annual risk of a person being hit by a meteorite, something you're not worried about in day-to-day life, like literally a rock coming in from the universe and hitting you, is estimated to be 1 in 17 billion. Equivalent to the odds of creating a few tens of trillions of UUIDs in a year and having one duplicate. In other words, only after generating 1 billion UUIDs every second for the next century will we have the probability of 50% of finding a duplicate one. Okay? So essentially, we expect centuries to pass, more potentially, but at least centuries to pass before any 2 computers produce an UUIDs that are identical. All right. So maybe universally unique is a little bit of an exaggeration. We should say centennially unique. I don't know what, but it'll be very unusual, unlikely. It'll be highly, nearly impossible for your database to be able to produce 2 UUIDs that are the same. Okay. And it would be highly unlikely within this coming century for 2 systems on 2 different ends of the planet to have the same UUID. So we consider them fairly unique. All right. So why do we like them? Because potentially we could make unique IDs across database tables. So that's kind of interesting. We can, like, I have a projects table and a documents table, right? I can generate unique IDs for both tables and not have to worry about, the same ID being used for 2 different resources. Okay, which means I could potentially even like have URLs, like this sounds a little crazy. I could have URLs where I don't have to specify /projects, project number /document number. I could just have a URL which is like name of the website /resource / ID number, because that ID number is unique for all the resources in my database. It doesn't have to be for a particular resource. Okay. It becomes really easy to merge records from different databases, right? Like imagine I'm running this application on one server and then I'm running it on a different server. If I'm using sequential IDs, these 2 servers will be generating like the same ID numbers, like 1, 2, 3, 4, 5, 6, 7. If I use UUIDs, they're generating completely different ID numbers, which means I can just take the 2 databases and stick them together. Done. I can merge them together. I don't have to create new ID numbers. Right? Whereas if I'm trying to merge databases which have the same ID numbers for the same tables, I can't do that. I have to create new ID numbers, then cascade through all the dependencies and update them. It'll be a big nightmare. But with this, I mean, potentially with this, for example, I could do something to, let's say, just crazy thought. When I get an incoming request to create a resource, let's say I have 5 different databases. I just send it to one of the 5 databases. And they don't have to communicate with each other to say, hey, what's a safe ID number to use? Just use a UUID. Bang, they're done, right? I don't have to like synchronize them in real time even, right? Um, so it becomes easy to distribute a database across multiple servers now, because each record will have its own unique ID, will never conflict with another. Doesn't matter which database I put it in, okay? And potentially, I don't have to like ask the database, what was the ID number you made? I can tell the database what ID number to make. I can generate the UUID myself and send that to the database. Or I could ask in modern databases, you can tell them, can you please make my primary key a UUID? They understand what that means, okay? A lot of modern databases do that, okay? And oftentimes, if you're using some kind of replication scheme, like you're making a database which is keeping like backup records or something like that, some of those schemes require UUIDs anyway. All right, so some database techniques require UUIDs. So UUIDs are great, but they're not like just completely like, they're not like milk and honey and perfect. Okay, um, there is a performance cost on using UUIDs because the database does need to check whether that UUID exists already or not. So there is a small performance risk, maybe not even small, I don't know. There is a performance penalty you pay because every time you insert a record with a UUID, for the database is technically required to check that that ID is not used anywhere else. If it uses auto incrementing, it never needs to do that check, right? UUIDs are big and ugly. That's a problem. So if you use them in your URLs, the URL is going to be like super big, right? And you know that, like if you go to like, if you go to, I don't know, I don't want to log in, but Amazon, and I click on a product. I mean, just it's already freaking ugly, right? I just clicked on a offer free. Hey, what's this? Free shipping to Taiwan, orders over 75. I take back everything bad I've said about Jeff Bezos. He's my hero. I should shave my head and put on a muscle shirt and look like Jeff. And say stupid things all day long. Okay, then my imitation will be perfect. All right. So free shipping. Okay, I completely forgot what I was talking about. That's great news. That's awesome. Because right now I have to always keep a little internal spreadsheet, like which of my relatives is in the US right now. Like, hey, when you come back, can you please bring back I quickly send stuff by Amazon to them. This is great. Wow. I might even join Amazon Prime again. Who knows? That's fantastic. Wow. Okay, cool. Free ship. Free. It's like, it's like a drug. It's like free. Lose all my sense. Okay. But you do see the point with ugly URLs, right? Like this looks like a UUID to me in here, does it not? Some of these parameters, I mean, your URLs become, I mean, forget human recognition again. Not only not human recognition, you can't even like copy and paste this into an email you're sending somebody. It'll look just completely ugly, so that's the downside that's one of the downsides of URLs. Free. Okay. And also, it's a real pain in the ass to debug URLs that are UUIDs. Like you're debugging and your ID number's like, it's like which resource was that? It becomes painful. Okay, so there's some downsides. There are other negative issues people have talked about, but these are the 3 that resonated the most with me, so I put them here. So but feel free to go read what other people think. Okay, all right. Okay, UUIDs. How can we create UUIDs? So in Ruby, it's not that hard. Apparently, what do I have to do? Apparently, I have to go click on this link right here, which tells me what to do. All right. So Ruby comes with a library called Secure Random. Okay. And you can require Secure Random. And then you can ask Secure Random to generate a UUID. Ta-da! Uuids. Okay, version 4. Now I know. So unless I'm the luckiest human being on earth, I should not get the same number twice. Yes, today is not the day to buy my lottery ticket. Okay. All right. So that's so as you can see, Uuids are pretty easy to generate in Ruby. Okay. I know what you're thinking. I know you're all disappointed. You're saying, but what about NaCl? Like, shouldn't we be like doing what, DJ Bernstein tells us to do? This feels like dirty. We're doing something that somebody else told us to do. Wait, I got good news for you. Guess how this UUID is generated. In most computers, especially Linux-based ones, what Ruby will do is it will not try to generate this number itself, because these should not be pseudo-random. They should be a little bit, I mean, they are pseudo-random, but they should be what we call cryptographically random, which is like an extreme high level of random. It's not like, Ruby or Python's or R's random function or sample function. Those are like baby random. We want like hardcore random, and your operating system, as I told you before, is one of the best generators of random numbers because it has access to sensory inputs that it can use in its random number generation. For example, I mentioned things like the temperature, your keystrokes, the delay between the keystrokes, your mouse movement. It uses all of that to generate random. It stores that entropy, and it uses that with essentially takes all that information and hashes it, or it runs it through a block cipher or a cipher of some kind. Okay, so it basically kind of encrypts that information, and that gives it random numbers. All right. So and I don't know if this happened to any of you, but for any of you, when you were creating your PGP keys, did any of you get a message from your computer saying, hey, not enough entropy to create the key? Nobody? Okay. It happens once in a while. Like a student will tell me, hey, I'm trying to make my key, but it's telling me I don't have enough entropy yet. Because again, PGP uses the internal random number generator of your computer. And if you just like opened it up and right away fired off, like, make me a PGP key, your computer can say, listen, I'm sorry, you need to run the computer a little bit longer so that I can collect more sensory information. Otherwise, I cannot generate random numbers, like truly random numbers for you. So how does the computer generate those random numbers? Well, first of all, where are those random numbers? I think I told you before. They are to be found in head, just gives me the first few rows of your, is it dev urandom? So you've got a file on your computer. It's not really a file, it's a stream. It's an infinite file, because if you try reading from it, you'll read forever. It's a stream of data. Um, it looks like that, but if I run it again, it'll look a little bit differently. It'll look differently every time I run it. So because dev urandom is a stream that your computer generates if you have a Unix-based machine, which is truly random numbers, or nearly truly. So it's using all the sensory inputs over the past several hours and passing them through a cipher. Anybody want to guess which cipher it's using? Edgar, in future, could you have like a little sound box every time people say cha-cha, it has a little cha-cha tune going on, like cha-cha? Okay. Okay, yeah, right. So it uses Cha-Cha 20, made by DJ Bernstein. We can breathe again. We're back in the safe bosoms of DJ Bernstein. Okay. All right. So secure random actually draws from dev urandom, which uses Cha-Cha 20. All right. At least Unix systems from 2016 switched to using Cha-Cha 20. All right. Now, how do we use them in our code? I promised you that the concepts are difficult, but this week, the coding is really simple. All you've got to do is go into your migration files. Sorry, you've got to delete all your tables. They're temporary, I hope. Okay. Delete all your tables, change your migrations. You're going to use, this time, just tell the migration I'm using a UUID for the ID. All right. And then it's a primary key. The definition is a little different. Previously, we said primary key ID. This time, we're doing it the other way around. We're telling it the type of value, UUID, It's called ID, and we're setting the flag. Primary key is now a parameter. It is. Please realize this is the primary key. Okay. Yes. Question. Yeah, you can do that. Talk to us a little bit on Slack about why you want to do that. Okay. I can see benefits of both, even of having both, but talk to us a little bit about doing that. Okay. Talk to us, because maybe you want to use the UUID for searching for parameters, but you want to use the ID internally for insertions and stuff like that. All right. It would make sense if what you're thinking is you don't want to expose the integer ID to people, outside people. You only want to expose the UUID. That could be one reason to do it. But it's also possible there's some other unique information that you can use as an ID. For example, username and project name would probably be a unique way of identifying a project. All right. So only if you cannot think of any unique combination of attributes that can identify a resource, then you can maybe generate a UUID on top of the auto-incrementing ID. Okay. Yeah. Okay. So that's UUID. For the migration. You also, in your SQL model, so that's the migration, in your model, you should also have the plugin UUID and tell it that the field we're interested in is called ID. All right. Why? It's possible for some databases, like maybe SQLite, that it will not do the UUID for you. So SQL, the ORM, has to generate the UUID prior to passing it on to it. Okay. Okay. One more thing, please. Do not store UUIDs as string. Don't be like, hey, I'm super clever. I'm going to make a string called ID, and I'm going to set it myself through code as a UUID. That's a bad practice, because UUIDs are not stored as strings in the database, because strings are long and very difficult to search over. UUIDs are stored in databases as 122 bits. So therefore, it's stored in its binary form, which makes searching it very much faster than searching a massive string. Remember, a string representation of a UUID is like 255 to the power, however big the UUID is, assuming you're using ASCII characters. Okay, so string representations are often longer than use more bits than the bits actually needed for the UUID. Okay, is that clear? Okay, so do not store them as strings. Allow your ORM to select the UUID type. So again, the reason I say UUID here for the SQL migration, if I'm creating a SQLite database or something like that, it's possible the SQLite doesn't know what a UUID is, and the SQL ORM will just take care of everything for it. But for advanced databases, the SQL ORM will realize, oh, this is a Postgres database. It knows what a UUID is. It'll delegate that responsibility to the database. All right. So allow your ORM to define this as, okay. Okay. So and that's that. Okay. All right. I believe setting the UUID in the migration basically tells the database to store it as a 122-bit number, not as a string. And the plugin in your model tells your application SQL model to generate those UUIDs. Okay. All right. Okay. Any questions about UUIDs? Use them when you think it's important. You don't have to use them for every single resource you're using. All right. Yes. Question.
If we want to test our API code, then how do we test that if we use UUID? The UUID is very
Well, share with me a test that you think will be difficult to do with UUIDs, and then I'll give you a solution. Okay. For the most part, for example, I don't specify the ID number in my tests. Rather, I insert something in the table and then I find the ID number. What is the ID number? All right. So, okay. So if you have tests that are somehow dependent on particular ID numbers, that's a little weird. So show me the test and we can discuss what's going on. All right. Now, the big kahuna, one of the big topics we're here to talk about today. So we're done with UUIDs. And yes, UUIDs are great because, they do help us to some degree to manage exposing sensitive data just by making the IDs unguessable in the URLs. Okay. And one more time, if you have resources whose IDs never show up in your URLs, probably no reason to have a UUID, I'm guessing. Okay. UUID is only effective because we don't want the end user to see the URL. Okay. Whew, let's stretch for the last push of the day. Encryption. So in my database, there are oh yeah, please.
Why does the UUID solve the problem about exposing sensitive data? Because
Yeah.
I think if we use ID on the URL, it's also it's exposing the sensitive data. But I use the
Right.
UUID is also the ID from the
It's
database.
true. The only minor difference is that people cannot guess the ID of your resources. All right. Like if I have, like, let's say I make a user account and I'm user number 35, I go to my profile, it's like user/35. I know the next user is going to be 36. I might be able to use that I might be able to do something really clever in combination with another attack. For example, I might be able to create a document and use some SQL injection attack to give the document user ID, owner ID 36. So the next time an owner comes in, they already have a document that's been inserted that belongs to them, which was created by me, not by them. They may download that and something terrible might happen, right? So I could use the information about the ID numbers to my advantage in combination with some other kind of attack, all right? But if I use UUIDs, I have no idea what the next user ID is going to be. Can't guess. Probably the next 1 million years that ID will not occur on any system on Earth. So it has no value. Okay. Okay. Right. All right. Question.
I wonder if in the future we'll do the authentication for user, so some user cannot like access some file like
Yes.
yeah. So what's UUID?
What's the value of then having it, right? Well, the story I just gave, where I use an injection attack to create a document or resource, and I change its foreign key to be, or I use a mass assignment attack, and I set the foreign key to be the ID number of a future user like you, right? Uh, and I can do that because if I can guess, like, oh, if I make a document, if I make my account now, I'm account number 35. Oh, Yenyu's going to soon join the system. She's going to be 36. So I use a mass assignment attack to make a new resource with owner ID 36. You log in, you come in, you create your account. You're now number 36, and in the documents table, there's already a document that belongs to you. All right. So I could use some kind of attack like this. So that's the point of it. All right. Um, make sense? So those are the situations we're kind of worried about. Okay. All right. Now can we talk about encryption? I'm dying to talk about this stuff. There's two types of encryption that is possible. One is called whole database encryption, where you literally tell your database encrypt yourself, all of it. And your database will, and you have to have like a username, password, and some key that will be used to encrypt the whole database. Okay. Whole encryption, database encryption, if you can do it, is fantastic. Please do it. All right. And of course, on our SQLite database, I don't think SQLite comes with whole encryption database, whole database encryption. We will use Postgres later this semester as our production database, but I gotta tell you something. We're gonna use the free version of it. Well, I mean, the free version already has encryption, but it's the free hosted version of it on Heroku, and they don't allow us to do whole database encryption unless you pay for it. Boo. All right. So we cannot do whole database encryption in this class unless you pay for the database. You pay Heroku for the database, and Heroku charges you a good amount of money for a database, like $15 a month for even a small, for maybe a millions of records. Like it's a lot of money. But setting up a database and configuring a database is probably more expensive than paying Heroku, honestly, because database managers are skillful database managers are very rare, very, very rare. And almost most companies with databases, they don't have very skillful database managers, frankly. It takes decades of experience to really understand how to manage a database, tweak its performance, set all the security parameters. It takes a long time to learn all this stuff. It's one of the most um, rare resources in the IT ecosystem, I would say. All right. All the other resources, programmers, analytics people, dime a dozen. But DB people are very hard to find. So for that reason, when a company that hosts databases for you, they can charge a lot of money because they know how much a real database manager would get paid, a competent one. Incompetent one would get paid very little, but a competent one would get paid a lot of money. So anyway, but even with your database encrypted, there's one more concern, which is that um, potentially someone could still access the database if they are somehow able to run within your Ruby process in some way. Okay, because for example, if you can run within my Ruby process, potentially you might get a glimpse of where my database URL is or something like that, and you're quickly able to access it. And if you're accessing it through my process, possibly you are accessing it with all the authorizations of my process and you're able to read it anyway. Okay, so whole database encryption mainly keeps out people with no access to your running process, but with people who are somehow embedded their code, they're able to remotely execute code within your process. They may still be able to read the database through your permissions because your process has permissions to read it openly. All right. For that reason, I also highly encourage you to encrypt the columns of your database that are very sensitive. You don't have to encrypt everything, but if there's any columns which are highly sensitive, please encrypt just those columns. Okay? So I will talk today about column encryption. All right? So I don't want to I want to set your expectations correct. All right? So and column encryption is kind of cool. We will do a very simple version of it today. I may show you a more advanced version of it later, but the simple version I'll show of you today is going to be simple. But for example, we could do more complicated things. Like for example, it's possible we could encrypt different columns in your database using different keys. We could do some cool stuff like that, and also protecting the columns of your database has one more advantage. Your database manager, whoever you're paying to manage your database, um, or your programmers, they likely already have access to your database and they can read everyone's information, which is kind of risky because your employees change all the time. So another advantage of column-based encryption is that even programmers and database managers with access to the database cannot read those columns because they're encrypted. And what you can do is you can keep the keys for encrypting these columns somewhere on a production server and have a core production team that takes charge of those keys. So even your regular developers don't have the keys that are used on production. They may only have keys for their local development. All right. So we can actually have different keys for development, testing, and production. And that way your developers don't even know the production keys, right? So even your developers cannot read your database. That's pretty cool. And your database manager can read the database because they know the credentials, but they cannot read the columns that are encrypted because those keys are kept separately from the database itself. All right. So column based, all right? There are some limitations, of course. Encrypting and decrypting has a performance impact. All right. And it also limits the kinds of searches you can do. You cannot search over a column that is encrypted because you'd have to decrypt the whole column and search it, and that's time consuming. All right. I forgot what this means. I was a smarter person when I wrote it. All right. Okay, so what will it look like? Let me give you a preview of what this will look like. Then we'll come back to the code to make this happen. Okay, preview time. All right, so let me actually git switch to my actual thing for today. Let me go ahead and delete the database and migrate it, my development database, drop it and migrate it. Let me switch to encrypted columns. All right, excellent. All right, okay. Now, I am within my, excuse me, rake console. By the way, I sometimes use pry and I sometimes use IRB. Pry is like IRB, but it's got a couple of other really cool features built in. One of them is, like I have to keep typing credence, colon, colon, project. It's killing these fingers of mine, right? Um, with pry, if you just want to operate within the credence module, you can just enter that module. You can just say cd, like, like in Linux when you change your directory, into this module. Now I can access this project and document without telling it which module it's in, because I'm literally inside that module already. So it's got that nice little feature, all right? All right, so let me create, so now I've got my database secured and I've got all the code done. So let me show you how it works, okay? So watch, I'm gonna create a project and I'm going to add a document to that project, okay? The project I'm creating the name is demo project. And to that project, I'm going to add a document, and the document has a file name, a description, and the contents. The contents you can see is a YAML file. Okay, it starts with dash dash dash, new line. So it's a YAML file, and oh my God, I've got a database key in there. Woo, secure stuff. Okay, so I do that. Now the cool thing is this: if I say I've got this project now, right? The project name is demo project, and the project has some documents in it, and the document has a file name, a documents at first dot file file name. So let me just do this. Doc equals project documents dot first, and the doc has a file name and it has contents. Ooh, what's it called? Content. Doc.content. Okay, doc.file name. Okay, so as you can see, these are not encrypted. This is the original values, right? Magician doing this trick, right? As you can see, my sleeves are rolled up. However, watch this. Let me go into the database and ask the database to just dump out everything in the database, okay? In the documents table. This is what's actually in the database. You will notice this file name and content is not in the database. In fact, there's nothing called content and file name. Oh, no, excuse me, file name is there. Description, sorry, that was the other one. Description and content are not there. Instead, I've got a column called description secure and content secure. And as you can see, these are encrypted. But what's cool is any programmer using this model doesn't have to know that there are secure columns. They can just say, description. They can just say content. So in the database, it's secured, it's encrypted, but when I access it, I'm getting it unencrypted. Magic. All right, how do I do this magic? So the way I do it is the following, and it's going to take me several slides to explain it to you. I am obviously encrypting and decrypting on the fly. As you are creating documents and projects, I'm encrypting them before they go into the database. When somebody asks for documents, I'm decrypting them as they're coming out. Okay, so I've written some code that's like encrypting and decrypting without the programmer having to explicitly say, please encrypt, please decrypt, okay? So therefore, whoever is developing the web application doesn't have to worry about encryption, decryption nonsense. They can just write like normal, all right? So so there's several things I've had to do. First of all, my database is being encrypted using symmetric key encryption. So I've got a symmetric key and I've got to store it somewhere. Where am I storing it? I'm storing it in secrets.yaml. This week, my secrets.yaml has a database key, a key that I need for encryption. Now, to do the cryptography, guess which library I'm using? Starts with R, B, NaCl. We should have a little dance for RBNaCl, like YMCA, but RBNaCl, okay? So we're using RBNaCl. However, now this is a design practice that I'm borrowing from my SOA class. I don't want to see RBNaCl code all over my freaking code base, okay? Because for two reasons. One, most of the developers on my team maybe don't know anything about cryptography and they shouldn't have to worry about RBNaCl, one. Two, maybe in future I want to replace RBNaCl with another package. I can't do that if every single, if I'm using it all over my code, I have to go Control F, find it everywhere, and it's going to be a nightmare to manage. Instead, what I'm going to do is I'm going to make a little library package that I can call, which does encryption and decryption. And under the hood, that library package just uses RBNaCl. So whenever I need to do encryption, decryption within my code, I can call my own little library, my own class, and tell it, can you encrypt this? Can you decrypt this? And I don't have to write RBNaCl code, okay? So this week, under the app folder, there's a lib folder for libraries, and I've got a secure DB library within which will do encryption and decryption on demand, all right? I'm going to change the migrations of my database tables because I will no longer have a database column called content and description. It'll be called content secure and description secure. I'm doing this because I'd like to be able to look through my database later and know which columns are secure are encrypted. Okay, so I'm changing the names in the database table, and then I'm going to change my models as well because my models are the files that are going to do the decryption and encryption whenever it's required. Okay, so it's actually my models who will do encryption and decryption, nobody else. Okay. And finally, I will change my tests a little bit this week, not only to check that I've encrypted things well, but also to check for all the other stuff that I did, mass assignment, SQL injection, to make sure I've done all those things as well. I've written tests to make sure I have security covering those problems. I'll show you those later, okay? Let's start with this secure DB library, because that's the RBNaCl code. Here's secure DB. And it's literally this file right here. That's all. That's it from here to here. Not that big. Okay. And honestly, you could, if you wish, just take the secure DB file and copy paste it into your project. It'll work because it has nothing to do with projects and documents. It's a generic security library that I wrote. Okay. All right. Let me show you what it does. And it may not be clear, like, why does it do this? Why does it do that? Let me tell you what it does, then I'll show you where I'm using it, okay? So class secure DB. By the way, I have created within this class another little class, which is an empty class called no DB key error. It inherits from standard error. I'm basically creating a kind of exception that is unique to my class, unique to the secure DB, okay? I'll show you where I'm using it later. Okay, first method is called generate key. All this, sorry, I had to reduce the font on it to fit it in. All this does is call RBNaCl and ask it, can you make a new symmetric key for me? All right, so one of the things this library does is it generates secure keys for the database, okay, with this generate key function. Oh, and it base 64 encodes the key. So you don't just get this big binary key, you get a nice string representation of the key, okay? Where do we use it? I'll show you later. Screw that, I'm going to show you right now. So I'm using that function only in one place. in my rake file, not in my application, in my rake file, I've made a task called, well, I've made a namespace called new key and a task called db. So if you run rake new key db, it will just generate a new database key for you, and it'll print it out on the screen. Okay. And what you can do with that is you can copy and paste that into your secrets.yaml file. So when you need to create the database key for your secrets.yaml file, just use this rake command, new key db. It'll give you your database key. And I have a different database key for development, for test, for production. There's no reason to have the same one, right? And yes, this rake task calls secure db generate key. I think that's the only place I ever call generate key. It's for the command line to be able to generate a new key if I need it. All right, okay, cool. What else does this class do? It's got a setup function, which all it does is it takes the environment variables in my config object and it passes it to this class. So this class can keep a copy of my configure. So config is that Figaro config object, which is all my environment variables are in that config object. Okay, that's all it does. It keeps a copy of my config. All right, what else does it do? Ah, look at this. It's got a function called key. By the way, do you notice these are all class level methods? These are not instance methods. I never have to create an instance of SecureDB. It's just a class. I can say SecureDB this, SecureDB that. I don't have to say SecureDB.new. I don't have to do that ever. Okay. So I've got a class level method called key. What does it do? Well, it first checks if I've got a variable class. This is a class variable, by the way, now, not an object level variable, a class level variable called key. If that already exists, then I return that because it gives me the key, the database key. Okay. If I don't have that, that means I don't know the key yet. I don't know the key for the database yet. So what I do then is I access my environment variables and I ask, what is the database key? And I store it in db key. And then I delete this from my environment variables. I don't want the key to my database lying in memory all day long for other sub-processes to read. Okay? If for any reason db key is nil, because I forgot to put db key in my secrets.yaml, then I will raise this exception, no db key error, which I defined up here. Is a kind of standard error. It's just a kind of error. Okay? If I do find db key, then I have to base 64 decode it, and that's my key, and I keep it in this @key object. All right, cool. Now, who uses this key object? Only the encrypt and decrypt functions ever call that key object. In fact, I should probably make this, is it possible to make it a private class level method? Maybe. Anyway, encrypt. You give me plain text, I call SimpleBox. Remember our good friend SimpleBox? What does SimpleBox do? It does a lot of things. You have to give it your key, of course, and then you have to call encrypt and give it the plain text you want to encrypt. But it does two other things. Anybody remember the two other things that SimpleBox does for me? Starts with an N. Nonce. It generates a nonce for me. So that way, think about this. This is really important because if I've in a column in my database, let's say there's two people with the same file name and or description. If I don't have a nonce, I will end up creating the same ciphertext for them, for the two people. That's dangerous because then there's a way to start guessing, right? Like people see duplicates. If somebody steals my database and they find duplicates in the cryptography, they can start making inference. They can start guessing what could that be, right? Is that a question? No? Scratching your ear? Okay. All right. What else does it do? Nonce. That's one. So that way, think about this. The same content encrypted in two different cells in my database will not have the same ciphertext. That's a big win. That's a big win, right? One more thing it does. Anybody remember? Starts with H, ends with Mac. HMAC. um, as part of the ciphertext, the secret key that was used to create the ciphertext is also used to hash the ciphertext and produce a digest at the end. And when I'm decrypting it, I will first use a secret key to see if that hash is correct. Otherwise, I know someone has tampered with my database. Wow, I not only have this encrypted with unique encryptions, it's also tamper-proof. Nobody can change the ciphertext without me detecting it. All right. This is the power of, the picture is on the next slide down here. We call this authenticated encryption. Authenticated because we know that the ciphertext, to check the MAC block, we have to rehash it with this secret key, which tells us whoever generated the ciphertext knows the secret key. And if only one other person like Alice knows it, then Alice made it. All right. Okay, moving on. So then so here's how encryption looks. It's so simple. I create the simple box, I give it the key, I then tell simple box, please encrypt this plain text. I get the ciphertext. Now the ciphertext will again be this crazy binary thing, object, which will print like blah, 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 blah. So then I just make the ciphertext, I just base 64 encode it. All right. Notice I'm using strict encode. I don't like the regular base 64 encode. It just has weird characters in there. So I use strict encode. If it's going to go in a URL, which this will never go, I will use base 64 URL strict encode, something like that, strict URL encode or something. But this is not going in a URL. This is in my database, so strict encode is good enough. Okay. The decrypt is the same thing. I create, first of all, I have to get the ciphertext and strict decode it, all right? And then I create a simple box with my key. Notice, every time I use this word key in encrypt or decrypt, this key is actually calling this method key. Because I didn't write at key, I wrote key. So if I haven't yet loaded the DB key, it does it right then on the fly. All right, it calls this method. Some people who are new to Ruby or even old to Ruby are like, why don't you always put empty parentheses around method calls, right? This is a method call. Ruby likes to have this gimmick or trick, or maybe it's a very nice feature, it's up to you, your philosophy, where you can call what looks like a object, but it's actually a method and it has behavior associated with it. So Ruby likes to kind of obfuscate the difference between an object and a method a little bit, because Ruby has this everything is an object philosophy. So even method calls can look like objects. You can kind of treat them like objects, right? Kind of. You can write them out like objects, not treat them like objects. Okay. So does that clear? Oh yeah, and then I go ahead and decrypt the ciphertext. That's it. That's all SecureDB does. Was that hard? No. Was it easy? Yes. I don't want to make you answer all my questions, so I answer the simple ones for you. You know, the easy ones, I'll tell you the answer. Is this cool? Awesome. Yeah, it's great. All right. What else do I have to tell you? In my environments.rb in the config folder, remember we made this environments.rb file, which kind of like actually creates the Rhoda API and does some configuration stuff. Within there, I call securedb setup config. What I'm basically doing is I'm passing the the config object that I made from this Figaro gem, and I'm passing it to the API so it can get the environment variables. Okay. Now, technically, I don't have to pass in the whole environment variables. I can just pass in the DB key. However, this is a personal thing. In my configuration, I don't want my environments.rb to know that securedb needs the DB key and the other guy needs this and that guy needs that. I just pass in the whole config object to whoever needs an environment variable. Okay. Okay. But do recall again, I am deleting this environment variable as I'm reading it. All right. This env.delete does that for me. Actually, you know what? I just realized something. I never use config. I don't need to do that setup. Awesome. Edgar! Edgar's like, why couldn't I be your TA like 10 years later when all this is like finally figured out? The reason is I did not adopt this policy of deleting environment variables until just some months ago. So I noticed, I was looking at the code that a professional developer put online, and I saw he's doing this, and I'm like, whoa, that's awesome. I'm going to do that. And that developer is Jeremy Evans, the guy who wrote SQL and Rhoda. He like put up some code for some other project, and I was like, whoa, if he does that, that's, I know he's very security conscious. So yeah, I'm going to do that. All right, cool. Awesome. That our code got easier. We don't have to do this environments DB business anymore. Nice. Okay. Rake file, I explained that to you. I made a rake task. Moving down. Secrets.yaml, I told you. For the love of God, please make sure secrets.yaml is in your git ignore. Okay? Please, 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 please. Do not put credentials in version control. All right. I told you that we need to change our migrations and models. Yes, we do, but the change is so blisteringly simple, you will love it. In the migration, I just changed the name of the columns from description and content to description secure, content secure. That's all I've done. Okay. I could do some nice hack where I can keep the names the same and just encrypt and decrypt on the fly, but I don't want to get that sophisticated. It is nice to be able to look at the database and know which fields are meant to be encrypted. Okay, so I call it description secure and content secure. So that's pretty easy to do. In the model, you literally just have to do this. So now I don't want people to have to access description secure and then decrypt it themselves. So in my document model, I just made a function called description. When you call it on a document object, it actually gets the called description. It actually gets the description secure and decrypts it for you. That's all it does. And I've got another method called description equals. If you're trying, this is a setter method. If you're trying to change or create a description, then it takes your plain text, it encrypts it, and then it sets description.secure to be the encrypted version of what you just gave me. Easy. Same thing for content. Content and content equals, same deal. All right. So for any columns you have that are encrypted, just make two more methods to create the safe versions of them, or the plain versions of them. Okay. Is that easy? Was that difficult? No. So I have to now go back to the story we looked at a long time ago, where we looked at this in week 2 or 3 or something like this, or maybe week 1. This is a story about a healthcare provider called Anthem. And Anthem suffered a hack where hackers stole millions of records of customer data from the second largest health insurer in the US. And this contained like birthdays, addresses, social security numbers, all kinds of good stuff, right? And Anthem released a statement saying they didn't encrypt the personal data of customers on the database prior to the hack. And the reason is because encrypting the data would make it more difficult for hackers to access, yes, but it would make it harder for the insurance company to analyze and share the data. Really? You're right. Sharing the data, I mean, they would have to share it in an encrypted format. They'd have to decrypt it. That may be true. But if you just want to access the data, ta-da! Just write a little wrapper around your data that decrypts it, encrypts it on the fly. That wasn't that hard, was it? Yes, you may take a performance hit. Maybe you have some analytics code that's going to go through like millions of records in your database and it's going to be slow. Fine. It's just analytics. It's not like patient data, So to me, I feel there's no excuse for companies to say, "Oh, we didn't encrypt it, it would be inconvenient." It can be easily gotten, right? I could write a simple Ruby script that could like now dump the plain decrypted version of this for an analytics person, assuming they have other safety protocols for the analytics person. And if we really say no, it's a problem because if we share the data, we have to share the decrypted data. Then first of all, that's not hard to decrypt the data and share it with somebody. The code's right here, right? And if someone says, well, but then they get the decrypted data, that's already not safe. Yes, but it's still safer to keep your own data encrypted, is it not? So to me, there's really no excuse. It's just incompetence. And I feel people just try to wrap it in other excuses. So to me, not an excuse I would accept. All right. And did Anthem ever get sued for this? They should have gotten sued for this. Anthem sued data breach. I don't know. Huh. Anthem settles, meaning they agreed we will not go to court. We will just give you $40 million to compensate for the breach of data. Okay. Even that I think is too small. Companies don't learn like their lesson if they just pay a few $1 million here and there. But at least that's a reason. Maybe that's a reasonable one. 40 million is still. Hopefully somebody's gonna get like in trouble. Okay. So yeah, they did get sued. They should get sued. This is such a stupid mistake to make, and then to make an excuse like it's inconvenient. Well, guess what? Your patient's safety is far more important than your convenience. Okay. Okay, I got a couple more things, and then we're done. Okay, you can stretch now. Encryption is over. What I told you is the hard part is over. That was the hard part. It's okay. It's okay. All right? It was okay. All right. All right. I got two more things to do. And but you can see today we're covering a lot of security topics, okay? And these are all basic hygiene. it's like it's like telling a child, please take a bath, clean your room. It's basic stuff. This is not like advanced stuff. It's just basic stuff, okay? So, and as you can see, this basic stuff covers like, I don't know, 4 out of 10 of the most popular attacks on people. Oh, and of course, what does this correspond to? This clearly corresponds to sensitive data exposure, right? Encrypt your damn database. Applications and APIs do not properly protect sensitive data, financial, healthcare, PII, personally identifiable information. Attackers may steal, modify weakly protected data to conduct credit card fraud, identity theft, and other crimes. Sensitive data may be compromised without extra protection, such as encryption at rest. Encryption at rest means encrypted when it's not moving anywhere, it's on the database. Encryption in transit means is the data encrypted when it's moving across the wire or Wi-Fi? Right now, if you do what we're doing, we can have encryption at rest. Encryption in transit means, which we're not doing today, is can we encrypt this when we're sending it over the internet between the API and the web application or the API and a mobile app? Can we do encryption in transit? We'll do that later. Okay. And require special precautions when exchanged with the browser. All right. We'll talk about browser and security. That'll be the last class of this semester. Okay. Before the demo week. All right. So as you can see, with the stuff I've shown you today, we've covered 1, 2, 3, 4 out of 5 of the top problems. We got it done in one day, folks. Of course, it works because we've spent all these weeks beefing up our cryptography knowledge and security knowledge. But we're here now, right? 4 out of 5 of the top things are done. 4 out of the 10 of the top things are done. A couple more things I want to do. One is I want to tell you, I think it's a really good practice. One of the issues in companies is not that they don't know how to do this, is that it's not in their culture to do this, right? Like they're like security, we just do that after a breach, right? Like we don't do that before our data is stolen. How do you change the culture of an organization? I don't know. It's a too big a topic for this class. It's a technical class in security. However, some practices I think should be slowly enforced. For example, since security is considered so important, why are your tests not testing for security? Test for security. Okay. So I do simple things like I have security tests for mass assignment attacks. So for example, I actually have tests that check um, that when I try to get a project that exists with some nonsense like this, that I should get a 404 and error from the API saying does not exist. Okay, and I should not return any data for sure. Okay, 404. Actually, it should be 400. Why is it 404? Oh, I had two different attacks. This was when somebody tries to change an attribute that they're not supposed to change, like created at. I give them a 400. With this, I don't want to try to parse an ID to decide if it is or is not a hack, because then it's tempting to go with that logic. If my logic is wrong, I'm going to make a mistake. So I just pass this on to my SQL, and if SQL can't find it, I don't care if it was a wrong ID or it was an injection attack. I just report 404. Okay. I don't think it's safe to try to do a validation to say, is this an injection attack? There are too many types of SQL injection attack. It's an ongoing cat and mouse game. You cannot keep up with it. So don't try to detect it. This is an obvious mass assignment attack, so I'm going to report 400. This is a SQL injection attack. Rather than try to detect if it's an attack or not, I just say I can't find it. Okay. And also, I don't want to give the attackers any information about whether this ID exists or not, or whether I detected that this is an injection attack or not. Because if I just tell them 400, this is an injection attack, they'll say, okay, so you know this attack. Do you know this other one? And they'll try another one. So I just give it 404. Okay, like I don't even know what you were asking for. By the way, GitHub has an interesting policy. I'll share with you maybe a later week, where if you ask for a GitHub repo and it's a private repo, they don't tell you 400 or 403 unauthorized. They say 404 not found. And I read their policy. I read something their developers wrote, and they wrote basically, we don't want to inform people whether that project exists or not. Maybe people are just like fishing and trying to see if the project exists. If I say you're not authorized, then they know, oh, so it's there, huh? So don't even have to tell, just 404, not found, none of your business, okay? We should change 404 from not found to none of your business. That'll be great. 404, none of your business. Some others checks that I do. This looks ridiculous, but I think that this reinforces security culture. I make sure simple things like when I make a new document, the ID of the new document is not a numeric, meaning it's not a floating point number, it's not an integer, it's no kind of number. Okay? It must be a UUID. Actually, an UUID will be returned to the database as a string. It will not be stored as a string, but will be returned as a string. But whatever is returned at, make sure it's not a numeric. All right. So that's just a little sanity check for me. All right. Just in case, who knows? Maybe later down the road, somebody will say, we don't need a UUID here. Let's make it back to a regular ID. The test will fail. We can have a discussion then, and also, this is going to sound a little crazy. I actually do tests where I insert a document into my database. I look at the secure fields and I make sure it's not the same as the unencrypted fields, right? Like, just in case I screwed it up and I wasn't really encrypting it or something ridiculous, I just do this little bit of sanity check, right? Is it encrypted? Yes, it's encrypted. Why? Not because I trust my code, because I tested my code. There's a difference. All right. Test your security. And I think this is part of security culture to me, is that it's formalized in our tests. So we know this is something that's part of our culture. All right. Any questions about testing? All right. I had a slide that I forgot to show about my controllers, and I will show that now, actually, under a different topic. No, I didn't forget it. All right. I had one more thing to cover, which was the last thing in the OWASP top 10 list. Last, but it is it is a top 10 thing. It's not like the least important, it's the least of the most important things, okay? Insufficient logging and monitoring. If you're not aware of people probing your system, exploring your system, trying to conduct attacks on your system, you will not know if you're under risk or not, right? It's like this expression, there are snakes in the grass, but you don't know if they're coming towards you if you don't check, right? So your system, when possible, when obvious that something happened that was clearly not just a typo or a small mistake, if something happens that you feel is suspicious, you should log it. You should keep a record of it. Okay. One of the things you probably know is that Rhoda keeps logs by itself. Like, for example, rack up. Oh, first of all, a rake console. Do I have some documents and projects? Yes. And it has a, does it have a document associated with it? Document at all. Yes, okay. Let's rack up. Oh, sorry. And what was the ID number? 1 for my project, okay? So let's rack up. As you're aware, when I go to localhost 9292, you know, I get this JSON credences up at this, and you'll notice that, you know, this is a message. It's saying from this IP address, I received this message on this date with this request, and this is a log. This is called your log. All right, it's a record of all the things that you've been that's been happening, and Rhoda keeps it for its own internal things. Where does this go? When you're running it on your local computer, it goes to your screen. Okay, obviously, right there. You could tell Rhoda though, can you please save this to a file instead? There's a configuration you can change, so you can save it to a file. We don't do that in development and testing because we don't need to keep that around. All right. In production, Heroku will keep it. It will divert the log to somewhere else. It will keep your logs for you for a certain amount of time. Okay. And I think Riley knows that we also use plugins, some third-party services in some of our software, like Papertrail. And in some of our applications, we actually export our logs to a third-party service who will do other kind of analysis or stuff with it for us, okay? But these are logs, and you should be sending stuff out here, okay? And apart from the default logging, so let me, let me go back to here. So now I'm going to say I'm interested in this slash project slash one. Oh, what happened? What happened? Project slash one, right? Oh, API v1 slash projects slash one. All right. Now, and you will notice in my logs, this is logged now. Somebody tried to access this project. So basic stuff is logged already. Wouldn't it be weird if suspicious stuff was not logged? I mean, we should be logging suspicious stuff as well. So what I've done this week is the end of the file, end of the last slide, almost last slide, application logging. So I'm setting up a logger so I can log things manually myself. All right. And to give you an example, let's go back to the mass assignment attack. Let me try to conduct a mass assignment attack. Excuse me. Give me a second here. I'll be done very soon, folks. Sorry to keep you. Let's go to where is my mass assignment attack? Why can I not find it? Where's literally the code I wrote for the mass assignment attack? HTTP request. What's the problem, folks? You're missing or you're all missing? And the only person who can tell us why is not in the room. Very sus. Ejected already. All right. I have to ask him okay. I think you got the original somehow, and everyone else got a copy. All right. Okay. Anyway, I won't go through it. Let me just finish up because I've used up a lot of your time. I won't do the demo. I'll just tell you what I want to tell you. Okay. So essentially, I'm setting up a logger, and what I want to do is I want to report things like this in my logs. I want to say, warning, there was a mass assignment attack and the person tried to access these columns. Notice in your logs, please never ever put the data of the request in the log, because that is stored somewhere, typically not encrypted. So anyone who's access to your logs, which can be like sysadmins and support staff, they can see like if there's usernames, passwords, content. That's terrible. Do not log that stuff. Okay. And there are attacks that have happened where people left sensitive information in logs. Oh, anyway, so how do I do it? Quickly, in my environment.rb or environments.rb, I forgot what it's called, I now require a gem called logger. It comes with Ruby. It's not like something you have to install. It just comes with Ruby, I believe, or it comes with Rhoda. It comes with somebody. All right. And what I do is I set up a logger object and I create a new logger. And standard error tells the operating system, anything I log, please send it to wherever you send error messages. By default, that's your terminal, that's your screen. On some devices, it could be something else. It could stream to a file. It could, like on Heroku or on our cloud provider, the standard STD-ERR stands for standard error output. So standard error might be a file, could be a printer, could be whatever you want it to be. Okay. Um, in old days, actually, in the very early days of computing, standard error was your printer, because your logs would come on the printer. Like you wouldn't keep it on disk because disk space was valuable back then. So you would have a printer at server rooms printing out requests. Okay. So anyway, so set the logger to that. I made a little function called logger. All right. And um, now when you're logging, loggers typically have this notion that there's different levels of messages you can log. The lowest level is debug, level 0. Info, warn, error. Error is critical, like a critical problem happened. Warning means careful, something suspicious happened. Info means I just want to tell you something, not important. Okay, 0, 1, 2, 3. In my configuration, you'll notice I'm saying in configure development and test, I'm basically using configure, by the way, comes from the environment plugin of Rhoda. And it allows me to say run this code only in development and test mode. So in development and test mode, I'm saying only report logs that are at the error level. I don't want every single log running, like otherwise when you're running your tests, you'll have logs, your log will be part of your test. It'll look really ugly. Okay. So only interrupt my tests and tell me that there's an error if it's actually an error. Okay. And then take a look. Now that I have mass assignment set up in SQL, if something goes wrong in my post route, this project.new or project.save fails, SQL will trigger a SQL mass assignment restriction error. So I rescue it here. I call my logger object and say, please make a warning message. Warn means warning message. That mass assignment, and then print out the keys. Only the keys, not the data. I know the data might be helpful to you, but don't log data because it can have sensitive user information in there. All right, so that's when you get something, and that'll print out something like this with a timestamp and everything. All right, and then halt with a 400 error and say illegal attributes. For standard error, if something happens that I did not expect, it was not a mass assignment restriction, standard error catches everything else, because remember, all the errors are inherited from standard error. All right, so if one of your errors doesn't catch it, then standard error will catch it. And here, I issue a 500 status code. 500 means it could be my fault. It could be the server's faults. So I do logger.error, unknown error. Okay, I don't expect any 500 errors even in my tests, because if I can test for it, then I should fix it. It shouldn't be a 500 error. Okay, so 500 to me is like I don't even know what the hell happened. So log it, and this time is a critical error. Okay, the warn, I don't know if there was really a mass assignment or somebody screwed up using my API. I'm not going to send them to jail for that. So this is just a warn message. Okay, so this will generate logs. So please log the things that could be happening. And when we put this on the cloud, what will be really cool is from your local development machine, you can contact the cloud and say, hey, can you just show me a live view of the logs? and it'll show it to you on your command line. It's pretty cool, right? Okay, we have covered a lot of stuff. We have more than what I've even written down here. So stuff like removing sensitive environment variables, preventing mass assignment attacks and SQL injection. This is all part of securing against known vulnerabilities in these systems. And for data integrity, things like sequential ID and UUID. God, I even forgot to write actually encrypt. Oh no, yeah, we already talked about cryptography, so I'm not going to put it here again. But you've got to encrypt your stuff and also log everything. With that, in 3 hours, I have been able to give you a fairly up-to-date idea of how to mostly thwart one, I don't know, like 4 or 5 out of these top 10. Okay. It's amazing how many developers out there in industry without this basic knowledge that I can give it to you in 3 hours, right? In the coming weeks, we're going to get to the more complex ones of authentication, access control, and stuff like that. Okay. And so this kind of ends the short 2 to 3 week module on web and databases, database-driven APIs. From next week, we're going to enter a topic. We're still going to deal with APIs, but we're going to start talking about the elephant in the room, users. What are they? Do they even exist? Do we have proof of their existence? And I'll send you a fun video that I'd like you to have a look at, which really asks this question: do users exist? Seems ridiculous, right? It'll ask you the question, do users actually exist? And should your code be talking about users? I don't want to give it away. We'll have a look at that. We'll come back and we'll apply that philosophical debate to our actual code next week. Okay? All right. Take care. See you then. Have a great, what day is it today? Weekend. Ever since COVID, I didn't